Hi everyone, my name is Deepak and welcome to the sixth lesson of Big Data course. In our previous lesson, we have already discussed about the different phases of MapReduce algorithm, and in our today's class we are going to discuss how MapReduce works. So in our today's class we are going to discuss how your MapReduce actually works. Okay, so for this question let us create one pseudo distributed scenario. Let us create here. This is your one machine, okay, and inside this let's create the different daemons. Okay, the first one is your this is your name node, this is your secondary name node, this is your data node, this is your task tracker, and this is your job tracker. Okay, we are now creating one pseudo distributed machine. Okay, what actually happening is in case your pseudo distributed mode, all your daemons are running on different JVM. Suppose this is your name node. Okay, so this name node, suppose it is running on your JVM 1. Okay, then your secondary name node, it is running on JVM 2. Okay, this is your job tracker. Okay, this is also running on your another JVM. This is your task tracker, which will be running on another JVM. And finally this is your data node. Okay, so these are the 5 daemons: name node, secondary name node, job tracker, task tracker, and data node, right? Okay, now let's see, you have one file here. One file is there. Okay, and something inside it. Don't care about content, just assume that this is your input file and the size of your input file is 300 MB. Okay, whenever you are submitting your job, okay, at that time the job will be submitted to your job tracker. The job will be taken care by this job tracker, and this job tracker will provide that job to the task tracker. Okay, let's say one example. Let's take one example. Your file is there 300 MB, which is the size of 300 MB. Okay, you know, whenever you are submitting your file on the whenever you are storing your file on the top of SDFS, it will be divided into multiple blocks, and by default in Hadoop your block size is block size is 64 MB. Okay, this is your default block size in Hadoop. Then your 3 MB of file will be divided into how many number of blocks? Let's check. $300 MB divided by each block size, 5 number blocks. Okay, that means your file will be divided into 5 number of blocks. Let's say block 1, block 2, block 3, block 4, and block 5. Okay, so your when you are trying to store your file on the top of HDFS, it will be divided into 5 number of blocks, and these blocks are stored actually in the data nodes. Okay, now suppose you have one job. Let's say you have one MapReduce job here. You have written some code and converted it into jar file, and now this is your jar file mr job, and now you are trying to submit this job to your cluster. Okay, you are trying to submit this job. This job will be taken care by the job tracker. Okay, this job will be taken care by your job tracker, and this job tracker will give this job to your task tracker for the execution purpose. So your task tracker will execute this job. Job tracker will give this job to task tracker, and your task tracker is responsible for execution. But internally what actually happens is, your task tracker will create another process which is known as task instance. Let's say this is your task instance. Your task tracker will create another process called as task instance. In the task instance, there are two things are there. One is your map slot, another one is your reduce slot. Okay, the first one is your map slot, and the second one is your reduce slot. Okay, and by default there for each slots there are two. Okay, I mean there are two map slots and two reduce slots by default. Sorry. Okay, so there are by default there are two map slots and two reduce slots. Okay, and each slot is responsible for execution of one block at once. Okay, that means at a time one slot is responsible to execute only one block at a time. Okay, that means when you are submitting this job, okay, and this and your file is already stored on HDFS, I mean in the data node, in the form of blocks: block 1, block 2, block 3, block 4 and block 5. And now you have submitted your job also. Your job will be taken care by the job tracker. Your job tracker will give this job to task tracker, and your task tracker actually internally not responsible for execution of the job. Your task tracker will create another process known as task instance. Okay, and in task instance by default there are two slots, two map slot and two reduce slot. All your map activities will be taken care by the map slot, and all your reduce activities will be taken care by your reduce slot. So for the first time, your block 1 and block 2, these two blocks will be taken care by these two slots. Okay, for your first time your block 1 and block 2 will be taken care by the two slots. Okay, so assume that your block 1 gets completed, but your block 2 is still processing. Okay, so as soon as your block 1 is completed, block 3 will be taken by that slot, and block 2 will still in process. Okay, suppose after some time block 2 and block 3 both got completed, so now block 4 and block 5 will be taken by the 2 slots. So like this your all the blocks will be processed. Okay, so this is the total process how actually MapReduce works. Okay, you are submitting your job will be taken care by the job tracker. Your job tracker will give that job to a task tracker. The task tracker will create another process known as task instance. In your task instance there are by default there are 2 map slots and 2 reduce slots. All your map activities will be taken care by the map slots, and all your reduce activities will be taken care by the reduce slots, and each slot will is responsible to process one block at a time. Okay, so this is all about your MapReduce working culture. Okay, thank you.